I'm going to share my screen. Continue. Screen one. Share. You guys see him?
Yeah.
Yep.
He's waving at us.
Is he?
Yeah.
Oh, there he is.
Oh, I just watched this the other day.
Who did?
Ryan.
Ryan Embry.
Ryan. All right, Ryan. I expect a little commentary, Ryan, since you fessed up to that.
He kind of looks like Ryan.
Yeah, a little
He
bit.
basically says, in a nutshell, it's not the things you would think of usually keeping yourself safe, like your physical and mental well-being and stuff like that.
Yep.
Okay.
All right, hang on. Here we go.
What's up, guys and girls? You're watching Bob Decline, lineman blogger. I've been a lineman on the east coast of Canada for about 17 years now.
A bit.
Since I started making YouTube videos, I get a ton of direct messages from guys asking for advice. What we're going to be doing here today is I want to go over 3 topics that I feel are extremely important words of advice for any apprentices out there or linemen alike. All right, first thing. You're going to want to show that you're interested in the trade and willing to learn. If every time your journeyman steps out of the truck to look over a job, you're slouched over in the passenger seat playing on your phone, he's going to think you simply don't care. The more you show your eagerness to learn, the more others will be willing to teach you. You're going to have to apply this to every aspect of every day. So make sure you involve yourself in any and all job discussions and planning, even if you're only there to listen. When there's downtime, make sure the truck is stocked up and that the tools and equipment are well looked after. My next words of advice is to look after yourself. Now, I'm not talking about leaving your brothers behind when something goes bad. What I'm saying is to look after your health. Being a lineman is extremely hard on one's body. We're lucky enough nowadays to have all kinds of tools and machinery to help us with this hard work. I want you to take the time to do things properly and use the equipment that you have provided to you. Now, there is a balance. Line work is still hard work. You can't be soft. But don't go being a show-off and end up ruining your back and shoulders before you even turn 40. Someone told me this when I first started, and I wish I had listened to it better. My final piece of advice for linemen is that you must understand the importance of being 100% accurate at all times. This one can be tough, but you're going to have to get used to it, because when working on power lines, there's no room for mistakes. When given switching steps, you are to understand them fully. There is no guesswork. If at any point you do not understand something, you are to stop and ask. If you're told to install grounds at pole 587 perhaps, they go exactly on that pole, not on the next one down because it's easier to reach, unless of course the plan's reevaluated and the whole team is made aware. This is very important in making sure that both you and your coworkers go home with all of your fingers and toes. All right, guys, that's it for today. Thanks for checking out another one of my videos. If you're not yet a subscriber and would consider doing so, it would greatly be appreciated, and it's a great way to support my channel.
Okay. He's got some good information there for you guys. We kind of touched on the first point that he went through last week was about being on your cell phones. That's not going to be permitted out into, when you get out in the field working, you want to make sure you have it put away. You don't want to be distracted for any reason. Unless it's an emergency, then you need to tell somebody you're going to step away and be on your phone or whatever. It's an emergency, but that's very distracting. This is not the kind of work you want to do where you're going to have that kind of distraction on you. Cell phones are notorious for getting people in trouble, not just for stuff they put on there, but for just being on them when you're not supposed to. So good. It's a good tool, but it can get you in trouble. Take care of yourself, like he says. Keep yourself fit. Don't do things that you're not supposed to. Don't abuse your body. This is a very physical job at times. You can see right now where he's at on the screen, walking through the snow. Been in many situations like that, especially up in the mountains around Asheville and those areas where, it's very physically demanded on your body. Not just the cold, but just, the physical conditions of having to do that kind of physical activity. Take care of yourself. And the last thing, what he talked about was know your limits. You guys, you really need to know what you can and can't do with somebody. Especially if you're working with another crew or something, and you know what you're supposed to do, what you can and can't do. Just make sure that you're doing the right things. Don't put yourself ahead of what what you're allowed to do is what I'm getting at there. So 3 good points. Professor Shoemaker, you got anything you want to add to it?
I think, yeah, especially as a new oncoming lineman into a utility and whatnot, it's I like the way he kind of put it there at the end. You gotta kind of throttle yourself as far as your initiative and motivation, and keep safety in mind all the time. It is one of those things I'm sure you guys are going to be thinking about here. Well, I want to do good and I want to do a little bit more. I mean, and it goes into the review process when you start getting evaluations or whatnot. What makes a needs improvement employee, or an unsatisfactory employee, or a meets expectations employee, or above meets, or exceeds expectation? What makes that kind of employee? And obviously the ones that exceed your expectations are ones that are doing more than what their classification asked for, like a line tech C, B, or A. That's hard to do when you walk into an organization, and I can pretty much guarantee you, gentlemen, the first year is going to be, I have never seen it. I've never seen an employee get an exceeds expectations review in the first year. It's more of a learning process, and you meet the expectations of the company. And then from that point on, you can get those. If you do bad, you're going to get low. And if you do good, you're going to get higher reviews. The thing is, you need to throttle yourself, and you need to be aware of safety in those cases. And it's like being a humble great lineman. You want to put it in that sense. You know your business. You want to learn a little bit more. You want to be more intense and more involved in what's going on in the job. And I'll put it to you this way. An engineer told me this one time when he was supervising our unit. One all crap can kill 12 attaboys.
Yeah.
You ever heard that before?
Mm-hmm.
So, you're getting, hey, attaboy, great job, great job, great job. You get about
Takes
a dozen.
one to ruin it.
All of a sudden, you have maybe a minor accident. You cut yourself with a knife or something. Guess what? All those attaboys are gone and out the window. So just be aware of yourselves. And I like the comment he made. If you don't know something, ask.
Yeah.
Ask somebody, hey, is it all right if I do this? Hey, can you come down and watch me do this? Or, get with me, be direct supervision. Can you do this? Don't get butthurt if somebody tells you no. 90% of that is you asked in the first place.
Yeah.
Okay. At least, you're showing a supervisor, or you're showing a fellow lineman out there. Well, at least he's got interest and he wants to learn to know what to do. But that's beyond your classification. Sit back, and guys are doing work over there that are above your level, and you kind of cruise and get on your cell phone, or can I take a break, or is it all right if I get a drink or whatnot? That kind of diminishes things. If you're sitting right there with them, watching them and asking questions as they go, that's going to boost you up. So you get the idea of what he's talking about there. Safety trumps everything.
Everything.
And I've done it before, and it was a good thing that you were thinking about. They put in our brains at Safety Cooper. If you approach something, if you start working on something, and a minuscule amount of doubt comes into your head, is this the way to do it? Stop. Don't carry on with what you're doing. Ask somebody what you need to do. Professor V?
Yep, I agree.
Okay.
Concur.
Any questions there as far as the video concerned? And we'll sit here for a second. I'm gonna throw out some information there, because I talked about reviews and whatnot. Different organizations have different review processes, and I have to tell you, to get an exceeds expectations, and I'll throw up a share screen here just to show you real quick. Let's share the whiteboard. See what happens here. Let me know when it comes up, if it comes up. You got it?
Nope.
Okay.
Not yet. Yep.
Okay. So our standard, each year you get like I think it was a 4-page review on different quality of work, quantity of work. And they even have grading on your attitude, your education. There's a bunch of different scores and review processes that go on in there. But as far as the review increase was concerned, you have 0. Wow, that is time. You had a 5, 4, 3, 2, 1, 0, and these are all percentages increase on your salary. This was the increase range. Professor V, anything different at Duke?
It usually was a standard across the board when the raises came out, like the increases came out.
So everybody got a 3, or
Yeah, pretty, and really, they were starting to implement it. It was like pay for performance kind of thing, what you're talking about.
right?
You know, but as it stands, when I left, it was pretty much straight across the board. If it was a 3.5%, everybody got 3.5%.
Okay, so even if you did terrible, you got 3.5%. If you did excellent, you got 3.5%.
Yeah, but they were changing that.
Okay, that's what they call a cost of living across the board.
Yeah.
Can you get that?
Yep.
Right. Santee Cooper is a pay for performance, was what you're seeing 5 to 0 as far as your increase was concerned. So a 0 was unsatisfactory. And we'll discuss that in a moment. 1 was a needs improvement. Two was a low meets expectation. 3 was a mid meets. 4 was a high meets. And 5% was an exceeds expectations. Now, Professor V, as far as Duke was concerned, did you have a manual or a book that was assigned to your linemen out there that in your first year you need to do this
Yes.
competently? Okay. Santee Cooper was the same. You're going to get a manual, and it's got tasks inside of it. And what they want to do is like change out a crossarm. And it's not, it's just like us. If you can do it as many times as you want to, and then when they feel that you're doing it competently, they're just going to check that off your book. Right? And you've got a certain task to do in your first year, for certain tasks to do in your second, third, fourth, and fifth, all the way up to line technician A. So you get all these things taken care of, and pretty much if you do very good and maybe take off some more stuff and are really the cream of the crop, you're going to get it exceeds expectations. Say you do your stuff in a little bit more, no accidents, no problems, high meets. All right, here's one right here. That's the typical one that's given out to most employees. Mid meets. Your company's going to tell you, and this is true, is you're doing your job and you're doing your job well. Don't get upset if you get a mid meets expectations. You can't let that one in. I don't know.
That was Randall.
Okay. Don't get butthurt here. Mid meets. I'm doing my job. I'm doing it well. This is a good time. If you want to, you have to get that review, is to go to your supervisor and say, and here's the way to approach it. What do I need to do to improve myself to get in the high meets and exceeds expectations range? Right? That's a good sit down with your supervisor. And and you see the way that I put it. All right. Did I say, what am I doing wrong? Yes, no, maybe so.
You're not exceeding the next expectation into the 4% bracket. You're not going above and beyond your 3% duties.
Yeah, but my question to the supervisor when I sit down with my review is, am I going to approach it as, what am I doing wrong? Well, why didn't I get a high meets? Or was my question, should my question be, what do I need to do as far as my work to be able to get to the high meets expectations? Which approach should you take?
I think the second one.
The
Yeah,
second.
the second one.
Yeah, great, fantastic. You know, and then a good supervisor is going to give you good instructions. He's going to say, well, focus on this, focus on that. Let's do a little bit more of this. You know, I got you a couple times on the cell phone, even though I'm going to give you a mid-meets. You know, just tighten things up a little bit when you got a good supervisor.
Yeah.
Okay. And do understand, you've got a company here that's going to come down on a service center or a organization, say a unit of employees, and the management's going to tell you, you can give in your unit a 3.8% increase. Now he's going by the unit. Okay. So overall, when it's said and done, when you turn in all your employees' paperwork for increases, it's got to be 3.8% or lower. That's what the main office is telling you. Well, that's between the mid-meets and meets. Usually, on a group of employee, this irons itself out. So I've got a couple employees in my unit that had a motor vehicle accident. Out of 30 employees, you know, a couple have a motor vehicle accident. Well, that's going to be a 0. Right? Any type of accident is going to be a 0. So that gives me more room for those ones that are high meets and exceeds to give them above 3.8%. You see how that works out right there?
Yeah.
All right. So don't get all upset if somebody comes to you, and especially in your first year, and says, you're meeting our expectations. And I like to tell the guys, you did a good job. You did a really good job. Okay. Low meets means you had a couple bumps in the road there. You had maybe, you know, I caught you a couple times. You're late, you're tardy. All right. Low meets, that's going to work on that. 1% is usually to the job performance that you're doing. You know, I like your motivation, I like your initiative, but your output is just not what it needs to be. You need to do some training. You need to do a little bit more in your work as far as that's concerned. And like I said, unsatisfactory here at the bottom usually relates to an accident or a safety violation that's gone on with you. And that's happened, and that's why you're down at 0%. Now, there's some things linked with the unsatisfactory going on here. You have 6 months to improve, to show improvement. And after that 6 months, if you haven't shown improvement, it's going to be time for termination. Okay. Say you fail a drug test, 0. I mean, there's a lot of things that can go on with that situation. So is there any questions there? So really, all these increases from 0 to 5 are going to be on your current income. So if you're making $20 an hour, do a little math here, and you get a 5% increase, what are you making now?
$1.21.
Yeah, 21, right? So, you know, it's nice. It's a nice little increase that's going on in this situation. It's $1 an hour in a year, that's fine. So I just wanted to put that across to you guys. I mean, you definitely want to have initiative, motivation, but when you start saying, well, I'm going to press a little bit harder and do a little bit more to get that 4% or 5%, make sure you don't have an accident or have a safety violation in those processes, because it's going to bump you right down to 0 and 1. Okay. Professor V, in his company, I know they have what they call goals, incentives.
Yep.
So you got incentives for, you know, you're going to get $100 for no accidents. They're going to give you $100 at the end of the year. Your unit has a good, your whole unit has a good safety record. They're going to give you another 100. All right. Your outage times are down. They're going to give you another 100. I mean, incentives go on through the course of the year. If you get that 0 unsatisfactory, that incentives check is also nullified. You don't get that goals incentive. Okay. I just want to throw that out there. We'll discuss that more when we talk about lineman overtime and all that kind of good stuff too. But just want to include that also. So no questions there, huh? Now I will say one thing. Organizations like Duke Energy, Professor B on the phone, he is, and Santee Cooper are, I don't want to put it in an incorrect way. They have a progression plan. Am I still sharing screen here?
Yes.
So they have a progression of 5 years to line technician A. Okay. So there's line technician C, line technician B, line technician A, and it's going to take you a total of 5 years. The reason why they are 5 years and not 4 is they train you in both overhead and underground. You will find some organizations where you're going to go into the company and it's 4 years, but you're going to be specific to either overhead, line technician A, or underground, line technician A. Is there any difference between the two as far as salary is concerned or money?
Yes,
Somebody say yes?
I think so.
No, there is not. Okay. An line technician A or a technician A is a technician A, period, whether he works overhead or underground. Okay. Overhead I'm going to tell you this. When you look at a lineman and you look at a lineman's world, what do you think has the most glamour? The most pop to it, the most advertisement to it?
Overhead.
Overhead guy.
Overhead.
Yeah, man. He looks cool on a pole. Everybody sees him every day. I can guarantee you guys the difficulty and the technical work that goes on in underground is hard, or if not harder, more difficult than overhead. Okay, so he's going to get paid just the same. Sumter Utilities came and talked with us, and Professor V could probably attest to this too. And they came and talked with us and said, the glory is not there, but the amount of work.
This meeting is being recorded.
Right now.
Wow. The amount of work and what needs to be done as far as underground is concerned, it is just as difficult. And Sumter Utilities has a lot of underground crews, and they place a lot of emphasis on the training for underground. So it has just as much importance to a utility as any other. If you guys go into the underground field and solely work underground, don't get upset. It's an open door there, guys. And you're going to get paid just as good, if not better, as you would as being an overhead line.
Yeah.
So some companies are going here and they got a 4-year. Now, those are major companies. I will say this for Sumter Utilities, Lee Electric, some of your other contractors. I have known of some of my graduates going out there and doing a first year, and the second year they're promoted to a line technician B, and in the third year they're promoted to a line technician A. Now that's a 3-year. And that's not all my students, all right? It's for the ones that are going out there that have graduated that really, really show what it takes to be a line technician A. And 2 is the contract service there has had a lot of turnover. Some of their linemen have either moved to another location or they've gone to a major company, whatever the case may be, and they emphasize much more training to those to progress those up to a line technician A. Now, as far as pay is concerned, Sumter Utilities is comparable. Right, Professor V?
Oh, yeah. They've done well.
Yeah. And they're going to pay you by location too. So South Carolina, you're looking at starting out at $18 an hour. You move up to Raleigh, you get close to a major city, it's going to be 19 or 20. Okay. So they're going to progress you up a little bit faster. Benefits wise and company wise, Sumter's right there at the top. I know some career Sumter people, and I know some that have moved out to other organizations. Any questions there? Yeah, don't discount underground. You get an underground crew, okay? And if the company offers it, I'll ask Professor B this because I don't know how their company does it. If they do a 5-year both overhead and underground, I mean, that's really the course you want to take.
Right.
You might get a job that lasts 2 days and it's an overhead job. Then you might get a job that's 3 days long. It's underground. They're utilizing their people to the best of their capabilities.
Exactly.
Professor V, how does Duke do it? Do they have specific overhead and underground crews and then you don't move?
It really depends on where you're at. Like you said, like in the big cities, the Charlottes and all, they, of course, you know, everything downtown Charlotte's underground. So they have specific underground crews.
Mhm.
But for the most part, I know with the part of Duke that I was in, you do both. You're basically overhead lineman with underground skills. I mean,
Right.
because the majority of what we did was overhead, but
Right.
a lot of underground going on coming into areas.
Sure. And you know, I'll liken to this and we'll take a little break here. You guys have been seeing those HTC guys coming out to the field on Fridays, right?
Yep.
Yeah.
Yes, sir.
You know, HTC is mostly underground. They have very little, they'll contract out their overhead work, but they've got very little overhead involved as far as construction is concerned. And you're going to go through your careers and see opportunities. If you see an opportunity to improve yourself, seize it. Jump on it. Okay. Don't just sit back and say, oh, well, I'll let Robbie do that. And, I'll just find out about it later. Those 3 guys, they got approached by their company and says, look, we need to do a lot of overhead work down in Georgetown. We're doing some conversions down in Georgetown and we need some climbers. Now, what you going to do when you get approached like that?
Raise my hand.
There you go. Got to raise my hand. Yes, sir. I want to jump in on it. And when you get in on it and start doing it, do it with every bit of motivation and initiative you got. Be the best that you can be in that. And guess where that puts you? You don't meet my expectations anymore. You're starting to get up in that high meets and exceeding my expectations. I came to you this year. I asked you to do a little bit extra and you did it well, That's what throws you up there. Okay. In those fields. Do you think that I got told to go to New York for Hurricane Sandy?
Mm-mm.
What did I do?
Volunteered.
Exactly. Volunteered in expectation that I was only going to get paid 40 hours a week. Okay. And you see how that worked out. What do you think my review was in that year?
5.
Meets expectation or
No.
exceeds expectations.
It exceeded expectation. I wasn't expecting you to go to Hurricane Sandy for 2 weeks and then do a great job while you were up there, you and your crews. Okay. That wasn't in the plan. All right. And you were safe and there was no problems while you were there. My boss, man, I appreciate the confidence that he had me. I mean, we drive up there, we get there, and I call him up and I said, Neil, where are we going to stay? And you know what his answer was?
What was his answer?
His answer was find a place to stay. This is your ball of wax. Handle it. Okay. Take care of you. This is you. I'm not there. You take care of it. So it's pretty much, I've got a credit card that's got a $25,000 limit on it. Handle it. I need to feed my guys. Handle it. I need to find them a place to stay. Handle it. I need guys that need certain types of material or tools they didn't bring with them. Handle it. It's kind of one of those things. Leave me alone. Report to me your progress. But I've got other things to do while I'm here in Myrtle Beach. You handle that situation up there. If you're constantly calling them on the phone, hey, I need this, or why is this going to happen? Or, I've got a problem employee. What are we going to do? Here's a great one. When we went up there, guess when it was? And this was a pain.
Wintertime.
It was election.
Ooh.
So a bunch of my guys come up to me. I want to vote. I kind of went back and says, oh, wow, what do I need to do now? I didn't know you guys wanted to vote in New York. So I went out. Yeah, it was the truth. I went out. I found a voting center. I said, what can I do with guys that are up here in Hurricane Sandy, and they said, vote absentee. So I got all the forms, had them all come in on scheduled times. They filled out forms. They were good to go. Do you think I called the boss man to find out what I needed to do?
No.
No, handle it. Okay. Let's take a break here. And what time is it?
8:36.
36. Let's be back at 8:50 and we will start working on electricity. Take a break. You know, I don't mean to get long-winded here, but I like giving previous experiences, as you know, Professor V does also. So I got a little bit more to add before we go into the electrical portion of today and your quiz and whatnot. As far as my career was concerned, you know, the progression was pretty straightforward. And through the first years, now the first year I got there, of course, and that back in that day, they had a lineman apprentice, they had a C, B, and an A. So I came in as an apprentice. And Santee Cooper at that time was really starting to go and start heavily into underground. So they hired 15 people at one time. And I was one of those. I was 18 years old. So that first year as an apprentice, you know, I got that meets expectations. But every review after that for the next 5 years, you know, mine were exceeds. So how did I do it? How do you think I did it? What were some things that I did that put me above and beyond?
Learn from others' mistakes.
Well, of course, I heard the war stories. Yeah, I'll take it like that. I learned from other people's mistakes.
Excuse me.
Excuse me, what was that out?
Yeah, I tried to turn my video on, it kicked me. I think it's my, well, I don't know what's my Wi-Fi. Every time it always pauses something.
That's okay.
But you learn from.
I learned from other people's mistakes, and obviously, I learned from my own mistakes. There were a couple things that I didn't do 100% correctly. Y'all know about my electrocution. Do you think that was a ding against my record?
Yes, sir.
Yep.
Yes, sir.
It was, and you know, it was. I think the way they took that was, wow, you know, he was 3 months in the hospital. We're going to try to do the best we can for him in that case. But you know, I share in part of that responsibility also in that case. But as far as the other things are concerned, as far as my career was going, every opportunity that I had out there to climb a pole, to work a piece of equipment, to learn and work a piece of equipment, or to, and I think this really benefited my work a whole lot, working overtime. Now, I will liken a lineman's career as to being in the military. You know, you might get that call at any time and you're going to have to go somewhere and do something. There's two sides of working overtime. How much money do you get paid? What's your salary, new salary?
Time and a half.
Time and a half, all right? That's 50% of the situation that's going on there. You're gonna make more money. The other part is you're gonna get experiences and work on things that you might have never done before. Okay, so you're into a learning process also. I think that's the other 50% of it. And your supervision and other supervision in your unit that you're working for is going to say, dang, Shoemaker's here all the time, right? And they're going to start, it's going to be a trend. Well, you know, Shoemaker's not on call. He's on call once every 5 weeks, but, you know, I need an extra man, or I can't get a hold of Ryan Embry. I'm going to call Shoemaker. So it's going to be, you're going to be growing. You're going to get the hours of experience on a normal working day, and you're going to get hours of experience off the job too. And you can write that down in your book, your progression book. So you can move a little bit faster in progression if you want to. But it just gives your employer that, I want to say, sense of, you get recognition. if you want to put it that way. And I know Professor V, as far as him working down in Andrews and Georgetown area. I mean, Professor V, you were all alone, weren't you?
That's right.
Yeah, he is he is a marketer for Duke Energy in the Georgetown Andrews area. He's got full responsibility. I'm sure of this. He's got customers that are calling him directly.
Woo, all the time.
At his house and home at all hours of the day and night, and he is there all the time. He represents the company.
Yep.
And obviously, I mean, that's why we hired him here at the college. He is very, very good at what he did. And the community recognized that. So I'm going through the course of my career, and of course, I'm a line technician. Hey, well, what do I want to do next? What's the next step?
Journeyman.
Learn different jobs.
Well, you want to be a crew supervisor. Now you want to supervise the linemen that are, that are working with you. So the next step was crew supervisor. I applied. The first time one came open, got it right away. So I was a crew supervisor for 2 years. And what's the next step? Well, area operations supervisor. So you're pretty much, you have an entire area like Myrtle Beach, Conway, or North Myrtle Beach, or Garden City. And you want to be able to supervise all of the line crews in that area, both overhead and underground, including the contractors. So how many times do you think I applied for that job? Take a guess.
7.
37.
37. No, there's not that many positions open at that time. I applied.
10 times.
Huh?
10.
I applied for that position 6 times. Okay, in a 2-year span, and they were moving a lot of people around, including Orangeburg. I live in Surfside, including that position in Orangeburg, including that position in Moss Corner. I'm telling my wife I want that position real bad. We're just going to have to move in that situation, and I get turned down. Well, I went to my manager, still the same manager I had for that whole time. I said, Neil, what do I need to do to get that operations supervisor position? What do you think his answer was? First, I didn't ask, what am I doing wrong? Why am I not getting this job? I asked, what do I need to do to improve myself to be able to get that position? And you know what he said to me? He said, Scott, I've got an area that's really short on technology. They're still doing everything by paper. They've got to tighten up in these couple of areas over here. I want to, maybe their attendance and tardiness is not that good. That's what I'm looking for in my next area operations supervisor. So what did I do?
You went and got a degree in computer science.
Fantastic. Right. I'm working during the day. I'm taking all the overtime I can, and I'm doing college courses at night. I got that degree, came back, put in for the next job, bingo, got it. Now I approached Neil and I asked him, I said, hey, did I get that job because I had a degree? And guess what his answer was? Maybe.
You got the job because you were showing that you can continuously learn.
There you go. Okay. He said, maybe that might have been a portion of it. All right. He's not going to the 100%. Yeah, you did this and you're going to get that, because he's going to tell the next people. He can't guarantee that for the next person that wants the job. Okay. So that's the mindset that I want to get across to you guys. If you see that opportunity out there, seize it. Okay. You might get no as an answer, but guess what? I'm going to recognize that you asked or you tried. And if you do get that position, give it 100%, and you get a good supervisor or a good coworker that works with you, that can talk with you after hours or show you things after hours or during hours. Okay, seize it. Now you got to be in that situation. I've had linemen that seize that, and here I am getting phone calls 2 and 3 o'clock in the morning. I've got a pole that's broken here. What do I need to do? Guess what? If you don't know what to do now, then I don't need you in that job. Okay. And that's pretty much the supervisor employee relationship that's going on there. I'm not going to give you something I know you can't handle. But if I know you can handle it and you've done it before, don't blow my phone up at night because you're starting to worry me. I was the first responder for Safety Cooper in the Horry, Georgetown area. And of course, they asked for volunteers, put my hand up. That responsibility was every trouble call that was assigned by the dispatchers from the Georgetown Bridge to the North Carolina state line, I got a phone call and had to respond to. So my supervisor tells me, you're going to be the first responder, before they said the whole crew. You assess the situation, you repair it if you can, if not, call in more people. Guys, I have to tell you, from the North Carolina state line to the Georgetown Bridge, I didn't come home for about 3 or 4 days. I'm sleeping in the truck. I'm just getting call after call after call after call. And my supervisor asked me how things going. I said, going good, a little bit tired, but I'm, eating here and I'm sleeping there. My wife is getting upset at me, but I'm getting it done. All right. You got to push it. You just got to push that limit as hard as you can while being safe. Any questions? All right. Appreciate that little backstory. I'm going to share a screen here. Professor V, can you give me your printout?
Yep.
Because I haven't imported yet.
Okay.
One thing I like about teaching these courses here, when we talked in math, and the way it's a constant, it's a constant building process. So some of these questions that you're going to get today on your quiz, we have been through before. I don't want to make them sound redundant, but that's the way I like to teach. And what you use in ELW 110 and 111 is going to go to 112. And eventually what you learn in 112 is going to go towards what you learn in 114 and 211 and 231. So if some of these sound redundant, no problem, but it's just constant reinforcement as we teach and we go. Okay, so let's throw a couple of things up on the screen here. Now we talked about before, what type of electricity is most, do you see that, Cher?
Yep.
Is most prevalent in the industry? AC or AC electricity, okay? And it's simply got to do with, gentlemen, the efficiency of AC electricity is better than the efficiency of DC electricity. Now, DC electricity can travel a longer distance, but AC, as far as the production of it and the distribution of it and the use of it by the end user, is more efficient overall. Now, does anybody know what I have up here on the screen?
Sound.
It's a sinusoidal waveform.
I'm glad you can read that. You can. Very
Flow
good.
chart.
Way to go, Lenny.
All right, way to go, Lenny. All right, really, you can shorten that up a little. It's called a sine wave. All right, and it's one waveform. And we're going to go back and forth on shares here. If you'll notice up here on the upper left-hand side, I've got a plus voltage maximum, and I got a plus voltage minimum. Now, here's where some people get kind of messed up a little bit. All right, they think this is positive and negative in DC voltage. It is not. Through the entire sine wave, I have one direction in AC. This is the going out direction, I'll do this in a regular drawing. I peak, and let's just throw a voltage up here, 120 volts. Then that voltage goes down, and then the other direction. Now at the bottom here, I still have 120 volts. Another thing to remember in part of this sine wave, I'm peaking here and peaking here, both at 120 volts. All along the sine wave, I have voltage. So halfway would be 60 volts and halfway down would be 60 volts. Voltage is present along the entire sine wave and is only 0 at one point. Where is that?
Equator.
Equator?
The starting point.
Yeah. You see this 0 degree point right here? 1, 2, 3 times. I'm at 0 in one sine wave. Now this is kind of a little bit hard to grasp because our eyes are not fast enough and we don't see in slow motion. How many times per second is there one sine wave in AC electricity in the United States?
60 times.
60 times per second, or 60 hertz. This happens when AC electricity is generated and consumed. So once every sine wave, I am at 0 volts. Anybody got a light turned on in their house?
Yeah.
Okay. So if this happens 60 times per second, 180 times per second, because it's happened 3 times in one, so 3 times 60 is 180, there's no voltage going to your light. 0. Kind of hard to conceive, isn't it? Does it look like your lights are going on and off?
No.
No, but the human eye is not fast enough to see this happening because it's happening so quickly. All right. 2 is whatever the light is, or whatever the piece of equipment is, there that it's using it is seeing this so fast it doesn't tail off so quickly. I'm building to a peak voltage, I'm falling from the peak voltage. I'm building to the peak voltage, I'm falling to the peak voltage.
So would the light flicker then if you had a slow motion camera?
Here, stand by. I know there are videos for it out there.
Yeah.
And you see how fast my computer is. Wow. Warp factor speed.
Telling you.
Mm-hmm. Then I got about 40 windows open here. So let's do a search here. AC, electricity, slow motion. I know there's one in here I've seen before of a light bulb. That street lamps might work too. Here you go. All right, it might be a little bit difficult to see from your side, but do you see the pulsations that are going on with that light?
Yeah.
It's really fast right now. All right, that's the AC sine wave going from peak to lowest. There he goes, even a little bit slower. Dim, bright, dim, bright, dim, bright. There you go, it's even slower. That's 1200 frames per second. That's 1 second equals, yeah, 40. So they slowed it down 40 times.
That's so cool.
Into that?
And even with the slow motion, it's still hard to see.
Yeah. So, you know, that gives you the concept, and well, not really the concept, that gives you proof in the pudding right there of how it's happening. But it's happening so fast, you cannot see it with the human eye as far as that's concerned. All right. As far as our electrical system is concerned, what you need to know right now is when you have AC generated, all right, and we'll go to the generation part in just a minute. One sine wave here, that's my peak voltage. There's voltage all along until you hit 0 here in the middle, and then voltage rebuilds and then hits 0. Now, why do I have 0, 90, 180, 270? Why do I have a degree measurement along the line?
Because the temperature will increase.
This is degrees in rotation.
Oh, okay.
Okay, this is degrees in rotation. So when was flipped to the generator here real quick. So when my coil is at 90 degrees in relation to the magnet, I'm at peak, it's turned 90 degrees. When my magnet's turned 180 degrees, it's at 0. When it's turned 270 degrees, it's at peak the other direction. And when I've turned one full rotation, it's at 360. So let's move over here to the generator. And I put a I think it's a 3-phase. That's the wrong one. All right, so I put a 3-phase generator around here. I can't speed this up and slow it down. But we'll use the A phase right here in our generator as the one we're going to focus on as far as the sine wave is concerned. All right, and we'll use the blue sine wave. So you notice when the poles are equal, I mean, when the poles are, you got to push, you know how magnets do, you got to repel and attract. So attract, repel as the magnet moves. And these are just simple coils of wire. Remember the 3 components that we need to make electricity. What are they? A magnetic field,
A coil
a coil, and what else?
and a load.
Ocean.
Motion.
Motion.
Motion, right? Magnetic field, coil, motion. This satisfies all of those 3 components. Once I get all those 3 components going at the same time and my motion starts, I'm able to produce electricity, current, okay? The reason why that we have one attracting and one repelling right here is because my poles, north and south pole, one's in attract, one's in repel, one's in attract, and one's in repel. That will give you how many times per second does this thing need to turn?
Hey, Shoemaker, I got a question.
Yes, sir.
Is the magnet turning itself or is something turning the magnet around?
Something's turning the magnet, and we'll talk about generation here in our next, not next session, but our next talk here today.
Okay.
This is generation. All right, so usually I'm using a turbine with steam or something like this to make this turn.
Okay.
All right, and we'll talk a little bit. This is a simple generator, gentlemen. I mean, you get down to a generating station, like an electrical generating station. Do you think I have a magnet that's this big?
No.
No, there's a different method that we're going to use, but I want you to know this in concept, and 2, how a sine wave is produced in AC electricity. Okay. All right. In order, if I did this in a DC form, for one thing, I would have a constant voltage that is good, but I'd have to convert it. I'd have to get it, convert it, store it, then resend it. It's just not as efficient as AC electricity is, and really the ease of production of it. Okay, any questions there thus far? All right, we might as well talk about this while we're sitting on this picture right here. How many phases am I using? Or
3.
3 phases. Now, Professor V, you there?
Yeah, I'm here.
We'll come to this after the break. Can you bring up that video and just have it prepared for why we don't use 4, 5, or 6? And it's on YouTube. You can look it up. It's real easy. Why we don't use 4, 5, or 6 phases.
Okay.
Okay. And it'll show that in the next session. You'll notice I've got an AC sine wave. It peaks on blue here. It goes and peaks lower on here. This is through time. If you see my mouse, that's the timeline of when things are happening. My question here is, can I produce peak voltage? So that's peak here and peak here on 2 different phases at the same time.
Yes.
Peak voltage, it's a multi-part question. Listen to it closely. Can I produce peak voltage on the blue line, green line, and red line, any of those 2s at the same time?
Oh, no.
No, you cannot. Why not?
They're oscillating. They're never
Right.
going to be on the same
Peaks are at different-
Sine wave.
Right. Look, my magnet's turning. It cannot be at two places at one time. I can't be at C and A at the same time. I can't be at B and A at the same time. I can't be at C and B at the same time because I'm rotating across this magnetic field around here at the same time. And you'll notice by the sine waves when you look at them when they're static right here. Blue is peaking, green and red are here. They're not peaking. Red is peaking, green and blue are here. They're not peaking. Green is peaking, red and blue is here. And you see the concept that's going on as far as this is concerned. Now I want you to write this down. This is very important, and I'll throw it over here on a share screen. Let me stop this share. There's a simple calculation to determine your voltages here in three-phase. Very, very simple. You'll use this for here for a long time.
Shoemaker.
Yes, sir.
It says I left. My Wi-Fi is acting funny right now. I just want to let you know I didn't leave.
Okay, bud. Well, I can hear you. Appreciate that. All right, so let me clear this off. Okay, get back over here. So in the previous, and I'll draw a little drawing here. So I've got a sine wave, 0, and this is what I like to do as far as the learning process. It kind of keeps your minds right. This is my N line, and I ground it. So what does that tell me as far as the line is concerned in relation to an electric utility and what you actually see constructed? This is neutral, and I ground my neutral. I got one sine wave. We'll call that A. I've got another sine wave, and I'm not a perfect drawer here. And we'll call that B. I've got my third sine wave. It's right up in here somewhere. Okay, and I'm really not concerned, but after this point. You'll notice right here, I'm peaking. The other two are not. Let's say my generator itself produces a voltage of 7,200 volts. Embry and the rest of you, can I peak two voltages at the same time? A is 7,200, B is 7,200, and C is 7,200. That's how much my generator produces, volts-wise. So can I take, is it allowable for me to take A and say 7,200 plus 7,200 for B equals 14,400? Is that acceptable? Excuse me. Is that the proper calculation?
No.
Why not?
Because they're all peaking at 7,200.
They're all peaking at 7,200, but in time.
They won't all peak at the same time.
Right. It cannot be at the same, peaking at the same time.
Not
Here's
possible.
the magic number. Write this down in your notes. Keep this in your books. There is a engineer's calculation out there that involves the degrees and the slopes and the time. There's a simple number. 1.7325. Notate it, put it down. That is what I like to call the magic number. So any peak voltage that I have, let me clear this off. Any peak voltage that I have, 7,200, is my phase, that's the phase symbol, to ground at peak. If I want to go 7,200 phase to phase, it's 7,200 times 1.7325 equals Anyone? 12,470. I think you guys have heard that number before. I know you've seen transformers with that voltage on it, haven't you?
Yep.
Transformer nameplates, correct. This applies to every single voltage that includes 2 or more phases. So I'm going to get you to do one here real quick. What's the phase-to-phase voltage of 120? Anyone?
Is it?
Give me 1 second.
Is it? You times that by 1.7325, right?
Correct. And your answer?
I got 207.
207.9. That's fine. You're at a 208. You'll see 208.
Yeah,
What?
I got the same thing.
Right. What's the phase-to-phase voltage for 19,900?
$34,476.75.
We round to 34.5 kV, kilovolts.
Yeah, that's what I got.
I know you've seen these before. That's where we're getting that calculation from. 19,900 phase to ground. All right, phase to phase, 34,500. Now you know the reason why we just don't add them together. Is because in generation, we cannot have 2 phases at the peak voltage at the same time. Questions?
No, pretty clear.
Okay, good. This is really has a lot to do with your safety also. All right. If I'm going to work on a pole, and remember from before, I have a 20 kV glove that I keep, and I have a 40 kV glove that I keep because my organization works these 2 voltages. Let's take this one out. It works 7,200 and 19,900 phase to ground. Why do I wear a 20 kV glove and a 40 kV glove when needed? Is it 7,200? Pretty much all my poles have more than 1 phase, right?
Yeah.
12,470. Or if I'm working at a 19,900 phase to ground voltage, they're mostly 34,500. So what kind of glove do I need to use? A 20
40
kV
kV.
and a 40 kV. All right. This, if you went phase to ground on 7,200, be a little bit of overkill. But I've got to prepare myself for all situations, which include 3 phase. So I'm going to wear a 20 kV glove and a 40 kV glove. It's very important when you gentlemen, especially if you go out of your system, first starting out, is knowing the phase to ground voltage and phase to phase. Because you're going to have to insulate for the phase to phase voltage. All right. I'll give you this part, and we'll take a little break here. Our organization, 20 kV gloves, 40 kV gloves. We travel up to, and I know we use this example a lot. We travel up to Sandy, and we meet with their safety specialist right there. And their intentions was, well, we're going to need you guys to work from 0 to 69 kV. What did I tell them?
We don't have the safety goes for that.
Absolutely. Absolutely. You told them right off the bat, we are not insulated to 69 kV. We are insulated to 34.5 kV. That's as high as we can go. He said, no problem. Appreciate you letting me know. And we'll just give you assignments up to that voltage. You've got to know the system that you're working on and be prepared as far as the safety aspect of it. Okay. All right, Professor V, anything else you'd like to add there?
No, sir, that's good.
Did you have different types of rubber gloves? I mean, different voltage values?
Yeah, ours were rated up to 25.
25 kV.
Correct.
The highest voltage you were working was what, the
13,200 phase to ground.
13,200. Okay. I will let you know, gentlemen, And let me clear the screen off. It's acceptable. Clear all drawings. So the highest potential 34,500 that we could work on, and we had a 40 kV glove. All right, that's one voltage that we worked. 12,470, and we had another glove that we worked with that. I can tell you right now, between the 12 and the 20 kV, you've got what, 7,600 volts of extra protection there, right? How much do you have on 34.5?
A lot.
5,500. That's a 40 kV glove. You're working at 34.5 kV. This attests to you, gentlemen, that you must test your rubber gloves before every use.
Yep.
When you start working these higher voltages with rubber gloves here, make sure they're clean. Make sure you test them, okay? Wear your rubber gloves and rubber sleeves. What do you think happens when it starts raining? Do you think that 5,500 is going to go down on its value?
Yes, sir.
Yes, sir. Things get wet, they're going to go down on their value right there.
30.
So you got to make sure, and that's why we're talking, you need to know how to compute your phase-to-phase voltages and the equipment that you use in those situations, that you check it properly. Okay, let's, what time are we holding here?
9:26.
9:26. Let's take another break here, and we'll say, and it's 9:26, 4 minutes. Oh, that's a long one. We'll say 9:40. 9:40, be back, about 13 minutes. Okay, so Mr. Lennon.
Yes, sir.
Go ahead and state that question again so I make sure we got it right.
Okay. So say you start a career with Sandy Cooper. You you take the lineman Class A route. But then you decide. I want to go. I want to go with the union. To be a journeyman. With your Class A lineman experience, transfer over or be taken into consideration towards your path to becoming a journeyman?
Okay, so I'm going to break that question into two parts here. One,
sir.
while all of you guys are at this juncture and point in time, of course, I want you guys to get a job and make tons of money as quickly as possible. Okay, do your investigation now first. When you get into an organization and you start working in an organization, make sure that this is the one. And there's plenty of ways to do that. I mean, you guys get an interview with a company, be prepared with questions.
Yes, sir.
They're gonna open that up, and you have as many questions as you can as possible. If you get the opportunity to speak with some of their employees. And what's life like at Santee Cooper? What's life like at Ori Electric? And do your investigation. I know I've probably said this before. I've had students in classes. How many jobs did you apply for now?
I haven't applied for any.
I mean, how many should you when you get ready?
Oh, a lot. I mean,
Yeah. Yeah, I had one student that was going through the course, applied for 15 jobs. Right, 15 openings at different organizations. You got callbacks from 12. And then you can start picking and choosing and investigating those organizations. Man, this is the one I really want. And, I'm going to ask these questions in an interview. And if those interview questions don't work out, well, I'm going to back out of that. I'm going to go with this organization. Pick and choose. Farm, if you want to call it that, the organization that you're going to work for. What I don't want you to do, and it's kind of, Robbie, how many different jobs have you had?
Including this one, 4.
4? I mean, through your lifetime?
Yeah.
Yeah. I've had, well, two. I've worked for power. Now I worked other jobs during, while I was working the main job, but two is, and this is my mentality. You might get a different mentality from other organizations because, I'm talking about the 70s and 80s. Now it's 2012. It's nothing for a person to have 5, 6, 7, 8, a dozen jobs until they finally find the location or the place that they want to make a career out of.
Right.
Me, and please take this as me as an old man.
Yes, sir.
My process is, if you walk into my organization and I look at a resume that's got 10 jobs on it, it's a red flag for me. Okay. Why can't you hold down a stable job? In the past 5 years, you've had 10 jobs. That, in my mind, now I'm going to say my mind, is a red flag. If you didn't do your investigation up front and you didn't find a company that you could work for, it's got more to do with you than it does with the company. You've had 10 chances. Why is it not working? Okay. That's me. All right.
Yep.
You're going to find some other people out in the world that's the norm. That's just the way things are nowadays. Okay. So the first part of your question is find that right career to start off with and stick with it. Okay. Once you're going to go in and you say, I'm just picking on you. I know this is kind of a scenario. It's not true to life. Well, I start working for Santee Cooper. I want to be a journeyman. To be honest with you, if you look at the pay that the company is giving you now and the work environment, and I'm going to include that too, journeyman's not going to make much more, and the work environment might not be that good. I mean, was it all daisies and roses when I was working for Santee Cooper for 37 years?
No.
I'm pretty
No.
sure.
No, but my benefits package, they were family. My crew members, I mean, we go out, the environment was fantastic. Everybody was looking after everybody. And I can tell you one thing, part of my work processes was I'm making good money and I'm happy at what I do.
Yeah.
And that's not only with the people that I work with, it's the people that I work for. Okay, that has a definite value in the company that you work for. So be careful. Don't job hop. As far as I'm concerned, you might run into an old man like me that's going to interview. It's going to think, well, he worked for HTC. Why did he leave? He worked for Ori Electric. Why did he leave? He worked for Duke Energy. Why did he leave? Because I'm thinking to myself, those are all reputable companies. Okay, so be careful on that one side.
Yep.
The other part of your question is, well, I'm working, and let's just say I'm working at company A, and I get to my line technician A level, and I want to make a move. Maybe it's my first time. I've got family in California, and I want to work for a union in California. What's going to happen there is, if you don't have the journeyman license or you're a line technician A, they will take you in on a probationary period if you get hired. All right. And that probationary period typically lasts either 6 months or 1 year. Then you will be bumped up to their top level.
Right.
Okay. What it is, it's just time to say, well, is he really qualified at what he's doing? And then you'll move on from there. I know that the practice was where I worked was, if you're a line technician A for a contractor and you wanted to get in the Santee Cooper organization, you were bumped down to a top level B for 6 months, and then you were brought in as a line technician A. Now, this is all a timing thing, guys. Okay. And really what happened? Are you going to take a cut in pay?
Yeah.
Yep.
Yeah.
Yeah, obviously. I mean, I might have been a line technician A for a contractor for 3 years. I mean, you're building in those 3 years. You're coming in as an entry level, top level B for 6 months, and then an entry level A. So you're going to have to rebuild to get back to where you were before. That may take 1, 2, maybe 3 years in some organizations. So you got to be careful there. If your income can stand it,
Yep.
and you want to work with that organization because of either location or company value, go for it. But there are some repercussions. Does that make sense, Mr. De Santos?
That answers my questions.
Mhm.
Yeah, and I mean, as far as choosing the right company, you know, that's exactly why I'm asking these questions early right now. You know.
Yeah. Fantastic question. But you guys are at the point now to where, and you know, this is obviously going to be happening in an interview or when you speak with an organization, is this is the one I chose. This is the one I want to be with. I'm going to make my career here. And I can guarantee you, when you start getting in an interview, you get questions and you turn that back around and you say, investigate the company before you go to an interview and say, well, I like your company values, which are quality of work, quantity of work, good stewardship, customer relations. If you know, most companies have a mission statement.
Yep.
If you know the company's mission statement and you regurgitate that to them, let them know I am like your company's mission statement and the values that it has, they're going, this guy's done some investigation. Okay, he's done some work to be part of our organization. So that adds value to you also in an interview. Professor B, what are your thoughts on job hopping?
I'm not a big fan of it. Don't like it very much. If you get, unless, you know, if you're improving yourself or, you know, moving yourself up and it's a better opportunity, no problem. But I just don't like going from job to job to job to job. You know, that it just doesn't fit well with me.
Yeah, you know, I've not asked this of a military man before. Embry,
Yes.
when you get an MOS, I mean, what does the military think of you? Well, I'm not liking this MOS. I want to change to this MOS. Well, this MOS is not. What do they think about that in the military?
Nothing.
You only get a couple chances to change it.
Okay, and
I
even
think,
at
I think
that,
it was like 2 chances. You were able to change it like 2 times.
so they've got a limit on it. And even when you do change it that 1 or 2 times, they're not really happy with that, are they?
It doesn't. It
It
doesn't.
just depends. I guess it just depends. I mean, your unit that you're with will probably be upset about it
Of course.
more than anybody, but
Right.
Yeah, but I mean, like, there's a process, really. You know, when you change your MOS, you know,
Yeah.
they usually have an assessment, like a test. Like, if you qualify, you qualify. For it. Don't you don't.
yeah, like as a fueler, I couldn't lateral move into like EOD because I didn't have any training in explosives. So
Yeah, that's understandable. But still, and to be honest with you, it still just leaves a bad.
Yeah.
It leaves
Quick,
an impression to me that it's not, something's not right in the one that you first got onto. Are there reasons? And you know, Craig Johnson, are there reasons for movement out there in the world? I don't. Does everybody remember what Craig said? And I asked a question specifically to hear what his answer was. You come start working for HTC, and you know, a lot of organizations do this. Well, you know, I'm watching you. You're really good with customers, and you're really good on the technical side. I'm going to move you out of service installation, and I'm going to put you in splicing. Okay, you're going to be a splicer now, and you work for Splicer for about a year or 2. Well, you know what I'm going to do? I'm going to move you out of regular splicing. I'm going to move you. If a company sees the quality in you and wants to move you, that's A-okay. I mean, you start becoming a fiber splicer. We're talking about up and up and up and up.
Big
You
money.
know, you're moving up and up. They're wanting to do something with you. As far as you, and you know, I don't want to get overwinded on this. I've seen guys in our organization make it all the way to line technician A. Well, I'm not happy here. I want to be a coordinator. Okay, guess what? Lowest level coordinator. They work for that for 3 years. Well, you know, coordinator's not to me. I want to be a line technician A again. Well, you got to start out as B and make it back up to A. Okay.
Damn.
Well, I really don't like this A position. I don't like this area I'm working in, and I want to work for substation maintenance. So they went down to a substation maintenance B and worked their way up again. You know,
Man.
nice guy. You just kind of get that. Is he ever going to really work anywhere? You know?
Yeah.
Okay.
what about for like people like me who have had several jobs before they start this?
When you say
Just-
several, I don't mean to pick on you. You don't have to give out private information. How many is several?
I probably had like 15 or 20 different jobs.
just relate to what's pertinent.
Agree.
And you know, try to use out there in the world what's pertinent to the industry. Now, I told
Right.
you how many jobs have I had? 2. Now, to be honest with you, I started working when I was 13. I worked at a restaurant as a busboy. Then I became a waiter at another place. Then I worked at another restaurant. Okay. And then I started working for Santee Cooper. Then I started working for a golf course. I mean, I could probably throw out a dozen jobs out there. Nothing was pertinent. Okay. I started working for Santee Cooper and I consider that my career.
Yeah.
And every time when I came to the college, you know how many jobs I put down I previously had? 1, because it was pertinent to the job I was applying for.
Right.
You don't have to include all of them.
Right.
Right. You don't have to do that. Include what's pertinent to whatever you're applying for. It's when you get in the organization, and I've told you this before, especially in Horry and Georgetown County, the electrical organization is tight. I can guarantee you, if Horry Electric let an employee go, and Santee Cooper called Horry Electric and said, "Hey, Craig, why'd you let this guy know?" There's an inside communication line going on. Well, he really didn't like the job. And of course, those questions are going to fly. Why not? Well, you know, he just wasn't suited for, or he wasn't happy with. And that just kind of gives the indication out there. Why not? Make the best you can of what you have. I'll give you one more example here. And we'll try to talk a little bit more about electricity. We've had Santee Cooper employees, and there was this point in time back in the early 90s where Horry Electric was offering more pay than Santee Cooper was. Well, what do you think happened?
Leaving. People started leaving.
Yeah, 3 people left and went over to Horry Electric. Okay, we just waved. Now I'm not going to say who the person was at that time, but that person waved and he said, "Hope you have a good life. Thank you for your work for Santee Cooper." But guess what that last ending line was? Don't come back. Don't come back. If you don't want to make your career with us, don't come back. One of those guys remained. 2 of those guys quit Horry Electric, and guess what? They were begging. Now, this is back in the 90s, a long time ago. Can I get back on with Santee Cooper? Nope. Found somebody to replace you. Okay.
I mean, wow, back in the 90s, yeah. But that's like holding a grudge against somebody, you know what I'm saying?
If you don't want to be part of my family, if you don't want to take the hundreds of thousands of dollars in training that it's taken to get you to the point where you are now, we've invested in you. I want somebody that's going to be part of my family for his entire career.
Okay, if you look at it like that, yes.
That's the way I look at it.
I totally understand, but I'm saying like from a professional standpoint of view, like outside, that's like, like, hell no, you left my team and now you want to come back. That's
what was their reason for leaving?
Money.
I mean,
More money.
The money. That's all it was. When I say that's all it was, that's what it was. It was the money. It was for no other reason whatsoever. Hey, they're getting paid more over here. I'm going to move. Okay. Now turn it around 5 years later, and that table flipped. Now we're making more than they are. Can I come back, please?
Well, I would imagine it also forced the company's hand, because if they leave, they have to fill those spots anyways, and then they're not going to say, "Hey, if these guys come back, we're going to fire your ass."
No company's going to leave you a reserve spot.
Yeah.
I refilled that position with a guy that wants to work with us for a career. You didn't.
I hear you.
Okay. All right. Any other questions there? Now, I hope I answered yours, but and through a little insight of how you should act as far as jobs are concerned out there in the world. Okay. So let's do, what time is it? 10 o'clock. Let's do a review of what we're going to have on our quiz today. And you guys are going to get an assignment today. And we'll go through that here in a little bit. All right. Don't answer these questions. How many is it, Professor V?
10.
Yes. Okay. All right. In the electrical utility industry, don't answer these. Which type of electric method is used, or what do we use, AC or DC? And these are multiple choice. Don't answer that. All right. AC electricity is blank, meaning it travels the conductor in two directions. All right, I'm going to throw these out. Don't answer it. Ascending, bidirectional, descending, unidirectional. A good something to look at to remember there was, remember what the video was when the snails were racing. Okay, they showed it on the wall. What are those? What's that answer there? Question 3, true or false? Insulators enhance the flow of electricity. True or false? Don't answer. Question 4, conductors have a very low resistance to the flow of electricity. True or false? Conductors have a very low resistance to the flow of electricity. Question 5, and we need to discuss this. We skipped over this a little bit earlier in the teaching of the process before. So let me get to my book. Stand by.
Page 17.
17? Wow, it's way back there.
Is that what you're looking for?
Yes, sir. So we skipped this the other day. We'll discuss the reason why, and most of it's in underground. I'm on 17 in the part of what they call semiconductors. Semiconductors are materials that are neither good conductors nor good insulators. So they're kind of in between. They don't insulate well, they don't conduct well. They're kind of in between in that process of insulating and conducting. They talks about the electrons. Semiconductors are also characterized by the fact that they are, when they are heated, their resistance decreases. So if I've got a semiconductive material in it, when we discuss this, it's in our utility, it's usually some type of plastic or rubber material, but very thin, that we use it when we use it in underground conductors. When we heat it up, the resistance value goes down. It becomes a conductor. And when I say heating it to very, very high temperatures. Does anybody remember closely what the temperature of an electrical arc is? About
3 times hotter than the sun.
3 times higher than the sun. So you're looking at about 6,000 degrees Celsius. So when that electrical arc occurs and I've got a semiconductor, it becomes a conductor and loses its resistance. So here's how the question goes. A semiconductor resistance decreases as it is heated. True or false? And if you want to reference that as far when you do the quiz, that's page 17, semiconductors. Okay. All right, you've heard this tons of times before. Multiple choice amps, current refers to the blank of electricity, pressure, flow, resistance, or usage. Don't answer that. Volts refers to the blank of electricity. Again, multiple choice, pressure, flow, impedance, or usage. Next question. Watts refers to the blank of electricity. Multiple choice. Flow, pressure, usage, or resistance. Do not answer that. Okay. This is going to be a new one on you also. We need to know this for the future. How many watts are produced by 1 horsepower?
What was the question?
How many watts electrical power usage, or what power usage in electricity value produced by 1 horsepower? That's a simple internet lookup.
Am I supposed to answer?
You got a multiple choice answer? No, you're not supposed to answer.
Okay, I was just making sure.
Okay, that's a simple internet lookup, and that's a multiple choice answer. 788, 786, 764, 745.7, or 100 watts are your answers. All right, question 10. What is the electrical frequency for the United States? So we just learned that this morning. As far as that sine wave is concerned, How many times does that happen per second? Your answers. Mix 97.7 megahertz. 50 hertz. My feet hurts. 60 hertz. Okay. So that's the quiz for today when you go on this afternoon. Again, we will text you and remind when it's available. You got till midnight tonight to do it. And I'm looking at 10:04, guys. I'm going to need about 5 minutes here. So if you want to take a real short one, well, we'll make it. Yeah, we got time here. We'll make it 10:15. Let's take another break here so I can prepare and show you what your next project's going to be. So let's take 10:15, be back.
I have a question, Mr. Shoemaker.
10:15, we'll be back.
Yes, sir.
What's your question? Things are slowing down over here. I opened up PowerPoint. Jeez.
Well,
Okay. So how are you going to start this thing out? Let me know when it comes up.
come on. Come on.
Yeah. You got it?
Nope,
Give it up.
not yet. There it is.
Okay, there you go.
Move on.
All right, so you're going to have a title screen, title slide, and it's going to be called Generation to Meter Presentation Project and by the person that it's done by. All right, the first component that you're going to have in here is generation. Now he's got power station, which is completely okay. As long as you know the processes here that are going on. Get this out of the way. All right, a power station or power plant is an industrial facility that generates electricity from primary energy. Most power stations use one or more generators that convert mechanical energy into electrical energy in order to supply power to the electrical grid for society's electrical needs. I would, and not to say that I got the perfect slideshow here, I just picked one out of the bunch. What does he mean by primary energy? What do most of our power plants or generating?
The source of the energy.
Sir?
The source of the energy, primary is the beginning where it comes from.
Okay, so what are they using to produce electricity? What are most power plants?
Hydraulic, solar.
Yeah. I was about to say,
Solar is not effective
wind
in
farms.
generation.
nah, they changed the word of solar though.
What was that, Lynn?
I don't know. Primary energy. Are you talking about the primary energy source?
No, I'm not. I'm what in the industry, if you were to think of a generating station right now, what do they use to produce
Turbines.
electricity?
Turbine building.
Turbines.
Turbines, but what turns the turbine?
Water.
Steam. What produces
Yeah.
steam?
Oh, coal.
Coal. There you go. Coal is prevalent. Nuclear is out there. We've got gas, natural gas. So if you could include that in that slide, those are the most popular that are out there. Solar, not as a generation project. I would not include that in there. Solar is used, but that's not on the generation like a plant that you.
Hey, Professor V.
Yes.
Not Shoemaker. Is there really changing the world into solar? Like everybody's going into solar? That solar power thing?
No,
Okay.
not yet.
Okay.
We'll talk solar later on in the course. Okay, so power station or generating station, however you want to put that. Okay, just go into Google. If you want to use a different picture, go into Google, type up utility generating station. Plenty of pictures out there.
Lots of them.
Okay, switch yard. Out of order here. All right. Switchyard, sorry about that. Switchyard is a substation without transformers that operates only at a single voltage level. Switchyards used mainly for connections and interconnections are essential for transmission, distribution, collection, and controlling the flow of electricity. So I picked one here. There should have been a step-up transformer.
Yeah.
That he didn't include. So it's power station, and I'll show you a picture of one after we get done with this presentation.
Oh, then it's a transformer yard.
Right. We're gonna take a voltage from the power station, put it to a step up transformer,
Then it goes to
take it to the switch yard.
yeah, because usually the transformer yard is at the power station or like close to it.
Correct, right at it. You are correct.
Yeah.
But I need to take a lower voltage, typically around 34 kV, and step it up to transmission voltages, typically around 230 kV and higher. So that slide is missing, but I will get you that information. We'll get done with this one. The next is the switch yard. So I leave the transformer, come out to the switch yard. Think of the switch yard as a train station. All right. So I can go into it and I can branch out multiple directions out of a switch yard. No transformation in the switch yard. All of it's the same voltage, but I can go different directions with it. Then I've got the transmission lines right outside of the switch yard. I now want to transmit my power out. So transmission lines are the conductors that serve as a path for transmitting, sending electrical waves, energy. Yeah, that's kind of a little bit too much in depth. Just transmission electricity through them. These basically form a connection between transmitter and receiver in order to permit a signal transmission. That's more.
So this is the next step after the yard.
That's correct. Okay. So transmission lines, and you'll see in the next slide, transmit electricity to substations. That's your next slide. And remember, this is being recorded, so you can refer back to it if you need to. A substation is a high voltage electric system facility. It is used to switch generators, equipment, and circuits or lines in and out of a system. It is also used to change AC voltages from one level to another and or change alternating current to direct current or direct current to alternating current. There are some errors in here. I want you guys to look up a utility substation and tell me what a utility substation does. Some of it's correct, some of it's not. Do I transform AC to DC and then set it out?
No.
No, we don't do that. We use AC all the time as far as our distribution. The transmission to substation. Inside a substation, bus bars, those are these bars right here, distribute electricity with greater ease and flexibility than some of other more permanent forms of installation and distribution. They are often metallic strips of copper, brass, or aluminum that both ground and conduct electricity. So I can ground these if I need to. But inside a substation, I need, because the amps are so high, I need a better conductor. So they use bus bars in a substation. Circuit breakers, careful. Incorrect picture here. That's a circuit breaker for a house. When you do a search, you want a circuit breaker for a substation. Remember, we're inside one. A circuit breaker is an electrical switch designed to protect an electrical circuit from damage caused by overcurrent or overload, perfect, or short circuits. That's all very good. Its basic function is to interrupt current flow after protective relays detect a fault. That description is very good. He's got the incorrect picture here. That's one for inside a industry or a home. That's not one for the one that's inside a substation. Then feeder line. After I leave the circuit breaker in my substation, you got that?
Yeah, who is it? Oh, Luke. Yep.
After I leave the substation breaker, oops, I went one too far. I'm going to have what they call a feeder circuit. It's the cable or other transmission line. It's not a transmission line, it's a distribution line that connects what? Wow.
What that connects
Yeah, this is all wrong.
Yeah.
This is all wrong. So hold that one. We'll come back to it. Wow.
all right.
Then off of my feeder circuit is what they call a fuse tap. So I've got my feeder circuit that's on top. Then off of that, I tap off on lines. Those are called fuse taps. So they have protective fuses when I tap off the main line, feeder line.
Got it. Awesome.
Solid tap. Now, solid tap is coming off the feeder line, but I don't have a fuse. Okay. So make sure you're descript and telling me Well, it's an unprotected, non-fused line from the tap line from the feeder. A wire that taps from the feeder to the distribution line, no fuse. So we're going along our lines and we're at distribution voltages. Now we need to step that voltage down so we can go to our house. Step down transformer. Step down transformers decrease the voltage of power streams received at the local distribution level. The long distance stream is first stepped down to a level acceptable for local distribution and then step down again at each consumer node. A little bit of terminology here I don't like. If we're at a primary voltage, feeder voltage, what do I need to do with that voltage before I send it to your house? What's the actual voltage?
240.
120, 240. So be descript in what a step-down transformer does. We learned that in math. Takes a primary voltage on the top, steps it down to a secondary voltage so you can use it in your home. That's a much better description. Secondary line. The secondary wire carries the lower voltage of electricity after it passes through the transformer. So I'm going to give a little time on both secondary and service line. We'll get to service line in just a moment. I have a transformer on a pole, and then I've got secondary lines, and this is part of the industry terminology.
Got it.
Okay. This is part of terminology in the industry. When I have a secondary voltage that goes, hold on a second. Boy, they like to talk, don't they? When I have a secondary voltage and I need a conductor of secondary lines that goes from structure to structure. You see how I'm following my mouse? If I go between pole and pole with secondary, that's called a secondary line. Pretty simple. So be sure to include secondary voltage between pole and pole or structure to structure. When I have a service line, that is actually going to the consumer. It's still secondary voltage. So let's use this as a example. I've got a transformer down here. I come with a line to this pole. That's my secondary line, 120, 240. As soon as I come off that secondary line and go to the house, that's my service line, still 120, 240. The industry differentiates between the two, just so you know. That's the line that feeds the house, that's service line. Secondary, that's the line that feeds from pole to pole, that's secondary, but they're all still at the same voltage. And then the meter. A device that measures the amount of electricity consumed by a residence, a business, or an electrically powered device. Okay, so let me escape out of this one. Which one did I need to redo there, Professor B?
Was that the circuit? No, bus bar, circuit breaker,
No.
feeder.
Yes, that was it.
There.
He had to do the feeder and show us the picture of the step up.
Yes, picture of step up, and we'll do that. Let me do here. Let's see, Joe.
And we have to make a PowerPoint.
Yep. We'll get to that in just a moment. Let's see. Try Matthew Melton here. He's a Google slider too. Generation to meter components. I'm gonna present it. Professor B, let me know when it's up.
Got it.
Okay, so let's go straight to those. All right, and this guy, he's got the generation slide, and then he includes a generation station. There are some pictures out there, guys, that if you get it close enough, this is the station, that's the step-up transformer, and that's the switch yard. You can use one picture for 3 different slides if you find the right picture. Okay. Step-up transformer. He just shows a step-up transformer picture. He's got that right. Switch yard. Then he shows the switch yard. Same picture as the other guy had. Transmission, substation, where do I need to, I need to go back to here. I'll show you a picture there. Transmission, substation, a step-down transformer. That is the true picture of a step-down transformer in a substation. Bus bar, he shows on a graphic. Breaker, that is an actual breaker in a substation. Bless you.
Thank you.
All right.
Big ass breaker.
Yeah, that's typical. And then voltage regulator. Oh, we forgot that one. Completely different. Voltage regulator, that is completely different. Feeder. All right, here we go. It's a branch in a network that connects smaller. God, why do these guys do this? That's incorrect. All right. Generatr. Let's just go view all. Can I not spell? Generatron. There you go. I think Elijah did good with me. All right, start slideshow. Generator, step up transformer. He just used the graphic. So you can use the graphic for a step up transformer like you see here. And that's just a simple search for on the internet. Switchyard, transmission, which he has in the background. It's got some transmission and distribution. Substation, perfect picture. Step down transformer, which he's using the graphic, that is fine. Substation bus, transmission bus. Circuit breaker, voltage regulator. This was one that was not in the previous slide. So after circuit breaker and a substation comes a voltage regulator. Be sure that you use a utility voltage regulator. The purpose of a voltage regulator is to keep the voltage in a circuit relatively close to a desired value. Voltage regulators are one of the most common electronic components since a power supply frequently produces raw current that would otherwise damage one of the components in the circuit. So that's a voltage regulator. Feeder line he's got, fuse tap he's got, solid tap he's got, transformer, and instead of using a graphic, he uses an actual distribution transformer. Secondaries, good picture here. Pole to pole, service line, transformer to house. And you see the service drops here. Service drop, service line, service drop, and he just shows an actual graphic. Electrical meter. That's a much better one right there. Okay. You guys got a week on it, so I'm sure that we can come into, we'll be on in the afternoons on these days, and we'll be on in the mornings. If you guys got questions on how to work on it or what you need to have done. But this is pretty straightforward.
Yeah.
And like I said, Google searches will help you out. The thing that you need to look out for is don't get electronics mixed up with utilities stuff.
Yeah.
That's what that guy did before. He typed in voltage regulator and he got an electronics voltage regulator. If you put in utility voltage regulator, utility generation, utility circuit breaker, you notice I'm using utility all the time, you're going to get the right photos. Any questions? All right. Who can give me the definition of plagiarism?
Copy and someone
Copy and
else's work.
paste.
Copy and paste. Now, not to say I don't mind if you do a little bit of copy and pasting. The thing is when I go through these presentations, I might call you up and say, in your description here, what does that mean? And if you don't know what you pasted, it's going to be a bad day. Okay? Know what your slideshow is about when you carry that stuff over. And like I said, we're here for questions. You got a week to do this. We're here for questions if you have any. If you want to get on Zoom and share it with us, we'll work together with you on it. Okay?
Yep.
You said a week.
A week?
Huh?
You got till Friday?
Friday.
Is that okay? You want yours is due tonight, Al. No, I'm not gonna do you like that.
Did he pass out?
Yeah.
I bet so, yeah.
Yeah. All right.
I bet so.
Gentlemen, are there, oh, Professor V's got a video to show. I wanted to include here why we use 3-phase and not 4, 5, or 6 phases. He's got a great video here to show you how that process works.
Okay, and guys, just to back up just a sec, when you get those presentations done, you can put them in the Dropbox.
Thank you very much.
You have a power generation emitter presentation in the Dropbox.
Well, hold on one second. Sorry about that. I appreciate you saying that, Professor. So you're going to go to let's see. You're going to go into your D2L. My screen might look a little bit different from yours. Of course, mine's all white. You're going to go to the course that you have, ELW 111. You're going to go to assignments, Dropbox. And you will see nothing carried over, V. Dang.
All right, let me share my screen.
All right. I have to create one.
Okay.
Let me unshare.
Okay.
Sometime today. Okay.
Share. See it?
Affirmative.
Okay. Put it in your Dropbox.
So it's assignments, Dropbox, and you will see a category, just like you're seeing right here. Now his is going to be different because he's a professor. You open it up, you can upload files to it, and you can upload links to it too. So if you're using Google Slides or Google Docs, you just paste the link in there. If you're using online PowerPoint, you can just upload the file to there.
Yep.
Or the regular PowerPoint or whatever you're using out there in the world. Does everybody have software or something they can make a presentation with?
Can you repeat that?
Does everybody have some type of software that you can make a presentation or a Google account?
Oh, yeah, I'm good.
Okay, sounds like everybody's good.
Okay.
All right.
Okay.
3, 6, and 12 phase power. Wow.
This guy here, he's a brain, I'm gonna tell you.
If I only had a brain.
He's a brain.
Can't you go to the library and make one?
Can I go to the lot? And
Yeah, you should be able to, bro.
Yeah,
And
you
just
Okay.
email it to yourself or save it on the drive or something.
Okay, bet.
All right. I'm gonna just do that then.
Okay. We ready?
I am.
Okay, here we go.
Why people chose 3 phases when they transmit power. Why not 4? Why not 5? Why not 12? And I realized that if you took a 3-phase transmission line and then you took a second one alongside of it, and you rotated this one 60 degrees electrically, you could put it inside of the first one. And the circle isn't getting any bigger, but now you have, it would seem, twice the amount of power. You would, in fact, have almost twice the amount of power. Now you have a 6-phase line instead of a 3-phase line, but the voltage per foot between phases is the same because
right there.
Okay.
Voltage between phases.
So what he's saying there, guys, remember that single phase sine wave we have, how many times per second, or how many times in one sine wave does it go to 0?
3.
3 times. If you have 3-phase or even 6-phase, look how close the peaks are together. See how close they are together at the top? That means you have constant voltage almost all the time. So the more phases you have, the voltage stays and remains the same, higher. Remember, that's our electrical pressure. So if we're able to maintain an electrical pressure that's almost constant, our efficiency, like he's saying power, our efficiency is greatly increased. So keep going.
By rotating the electrical angle. If that works for 6, why can't you put another 6-phase line inside of a 6-phase line, rotate it a little more? Now I have 12 phases. If that works, why can't you do it again and again and again until you have a tube that is a conductor longitudinally, a funny material, but it's an insulator circumferentially. It's an anisotropic tube. And if you want an interesting adventure in mathematics, figure out the characteristics of that tube. It's doable. But in a more practical vein, during PTI days, we proposed some serious look at the 6-phase and 12-phase line. It turns out that the gain in power is not proportionate. 6-phase almost doubles 3-phase. 12-phase does not almost double 6-phase, so it's a diminishing return. We actually built, PTI had a test site in Malta, and we actually built, I made a model of it at the time, I still have it, of how a 6-phase tower might look with these blue lines are the insulators. Here's another one with a center conductor. We built such a line, I tested it. It worked exactly as you would predict it. So the math proved itself. Nobody was surprised. And, one got a little excited about it until you realize that a 3-phase line, when it goes into the substation, has 3 circuit breakers to open it, close it. And throughout that substation, there are 3 bus bars that these connect to. With a 6-phase line, there would be 6 circuit breakers and 6 bus bars. 12 phases, there would be 12 circuit breakers and 12 bus bars. So the complexity of coupling it's called a high phase order line, of coupling that into a substation sort of defeats the economics of it.
There you go. You can pause it there.
Period.
So you're looking at all the way from generation and even down to the meter in some cases when you're using 3-phase at the meter it's just not cost efficient. You have to actually, for 6 phases to work, build a duplicate system. You have to double your system. So for 3 phases, now you got to add 6 phases. For 3 circuit breakers, now you got to add 6 circuit breakers. In your generating plant, now you've got to have a 6-phase generator. You're going to have a 6-phase step-up transformer. So the economics, that's really where it gets defeated, is why it's not practical to use more than 3 phases. 3 phases, as far as economics, the material and equipment needed to do it, plus the room, the space to do it, it just does not work. So keep going.
Periodically, people raise the question because it would be possible, for example, it's very easy to couple from 12 phases for a transformer down to 3 phases. But But it remains an intriguing concept, probably more useful for power educators than for transmission line companies.
Okay, so I mean, we're talking a brainiac there, of course, but it does give you the idea of why we use three-phase and three-phase and no more, and what happens in the cases of when we do use it and why we don't use six phases. Our utility, as far as its operation is concerned, economic side, if I can maintain my voltages in three-phase.
Can I ask you a question?
Not yet, until I'm finished. All right. If I can maintain three phases and keep that voltage level up all the time and not have it dip into zero to a single phase, then my system becomes much more efficient. Go ahead with your question now.
How much do it cost to run actual generator place?
Depending on the size of the place, what do you think is the most costliest part? As far as running a generating station, what do you think the most costly part is?
It's creating the power.
It's the fuel.
Yeah, definitely.
The fuel is the most expensive part of running a generating station. As far as the plant is concerned, golly, Al, I mean, you're looking at, well, when the nuclear stations started the build at down in Summer Nuclear Plant, they started that new build. That was $17 billion.
Wow.
But they produce so much in a day.
Yeah, that part.
True, and you got to
Like
remember, and it's kind of, I want to say it's kind of, it's part of the industry, guys. When you go out there and let's say you're a manufacturer of boogie boards. How long do you expect that boogie board to last?
A couple of years, maybe 5 years, maybe.
Yeah,
Who
you're
knows?
gonna get a summer out of it. It's gonna get beat up, and it's gonna be good to go. Say you're a water and sewer company. How long do you expect that water to last? As long as it takes to get to your house and flushes it down the toilet, really. Okay. The electrical industry is longevity. I mean, a transformer, if you maintain it, and it really takes a very little maintenance, will last forever. Right? Transmission, and think of this when you construct stuff out there in the world. You set poles, you set steel poles, concrete poles, wood poles, and you do that construction on that pole, or you're putting underground in. Our expectation is, I want that thing to last at least 35 to 50 years on the initial install. So you want to get a lot of longevity out of your system. I mean, the Conway, who remembers Granger, generating plant over here?
Mm-hmm.
I mean, that was built back in the 1950s, guys, and it just got decommissioned. So you're looking at 60, 65 years of operation through preventative maintenance.
But what does it take to own one though? Do I have to get like is it okay to start like power plants in South Carolina?
You want to start your own power plant?
Yeah.
How much are you going to charge the customer?
I mean, it depends on once I sit down and do the numbers. I mean, typically it seems like from the rate that it's going at, it's probably like $1.13 per usage. That's what I'm looking at. I think it's a little cheaper than that, 97 cents.
Man, you're killing me, bro, because I'm only paying 7 cents.
7 cents?
7 cents.
Yeah, you're right. Yeah, that's what I'm saying. It's 0.09. That's hundreds. So that is cents.
Correct.
Yeah, so that'd be like 8.
So you're gonna tell me, and this is how it's gonna work. If you want to build a generating station in the state of South Carolina, first you're gonna have to find some land.
Okay.
Okay. Then you're gonna have to get all the permits.
Uh-huh.
All right, and then you're gonna have to get all the equipment. So how many customers do you want to feed?
Well, we still recording. We'll talk about that later.
Okay, hold on.
Huh?